In this video, I showed the relationship between the Rayleigh distribution and the Weibull distribution. We begin with the Rayleigh distribution. This is equal to RA formula. Let's start with the exponent function. Exponent of the x values. And the Weibull is equal to RA formula. Weibull of the x values where the alpha is equal to 2. And this is our sigma, which is, we'll find out at sigma, and 0. And our value for sigma will be data validation. List of items from 1 to 3. So our sigma will start from 1 up to 3. And we'll continue with this. There's a square root of 2. So we multiply sigma by square root of 2. So sigma square root of 2. And here we modify, starting with the exponent, that is negative 0.5x squared over sigma squared. So minus 5 minus 0.5 times x, and this is squared raised to the power 2, divided by sigma squared. Next, we've done this part. Now we divide the entire exponent by 2. So divided by sigma squared. Sigma squared. So divide the exponent by sigma squared. And finally, multiply x squared. So times the x values. Now they're all in the same trend line, and their data sets are the same, and their polynomials are exactly the same. Now we continue with the cumulative distribution function of Rayleigh, which is equal to our formula. Let's start with the exponent of the x values. Next, it's negative 0.5x squared. So that's minus 0.5 times, and this is x squared raised to the power 2, divided by sigma squared. Sigma squared. That's the exponent. And we'll factor in 1 minus exponent. So this is 1 minus. This will be 1 minus 1 minus the exponent. So that's the exponent. And finally, the Weibull function. This is equal to R formula. Weibull of the x values where our alpha is 2, and this is our sigma times square root of 2, and it's a cumulative distribution function, so the type is 1. Now they're all in the same trend line. Their data sets are exactly the same. So we can start with, we have started with 1, we can continue with 1.5, then 2, then 2.5, and 3. So this completes the use of array formula, data validation, to generate the trendline and trendline polynomials of the Rayleigh distribution and the Weibull distribution.